Hello and welcome to this solution video. If you like this effort of mine, please give it a thumbs up by liking this video, share this with your friends and subscribe to Math United. I'll try to be as detailed as possible to make you understand the concepts as well as solve the whole questions. Let's start with question number 1, which is about circular measure, where we have this OB 13 centimeters, the radius is 5, AB is a tangent to the circle. They're asking us to find the angle AOB, this one. Let's call this angle theta. Okay, so we know that the radius and tangent always make a 90-degree angle with each other. That makes it a right angle triangle. We have to find the angle theta with the help of the radius and this 13 centimeter side. So we can use cos theta. Why? Cos means it is adjacent to the hypotenuse. Hypotenuse is OB of this right angle triangle. Adjacent side is 5. So theta is cos inverse 5 over 13. Yeah, this will be 5, this will be 13. So theta is cos inverse 5 over 13. And they're asking us to give your answers in radians. Since answer is in radians, we will use 3 significant figures if it is non-exact answer. Of course, it will not be. So theta comes out to be 1.17600. So I will write 1.18. Okay, 3 significant figures. That's the answer of part A. Let's go to part B. Find the perimeter of the shaded region. So I'll have to find the perimeter of the shaded region. This perimeter is being made by this tangent, this line, short line, let's call this one MB. So this and this arc, these three lengths we have to add and it will become the perimeter. Okay, so let's start with not this is the arc. Okay, the arc. So arc AM is r theta. That's what the formula is in your formula sheet. R is 5. Theta we just got in radians 1.18, or I will use the one I got in last step, and that will be our arc. Now we need to have MB. The line segment MB will be OB. If I remove this radius from OB, I'll get MB. So 13 is the total length. Out of that, I will remove the radius. If it is 5, this OM will also be 5. That's why I've removed 5. So it will be 8 centimeters. Done. The third thing is this AB, and AB can be found out with the help of Pythagorean theorem. So AB square will be equal to the hypotenuse square minus, not add, okay? Minus, because hypotenuse is always the biggest line, so we have to subtract the other one from it. So AB comes out to be 169 minus 25 square root. Yeah, so it will be square root 144. So square root of 144 is 12 centimeters. So we have all of them. Perimeter will be 12 plus 8, this one, plus 5 times 1.18. And I'm going to use the last answer in this one. Let's do this. 20 plus. I'll find this out. By the time I do this, I would request you to like this video, share with your friends, and subscribe to Math United. What I'm getting is 5.8800, so 5.88 is the one. And total we get 25.88 centimeter is the perimeter, which we can write as 25.9 centimeters. All right, they have should be a question based on the area of the shaded region, C part, and it's there. So I will use this part. Okay, so the area of the shaded region will be what? I'll find the area of the triangle, this whole ABO. So area of shaded region will be area of the triangle AOB minus, from this, if I remove this sector AOM, this sector, it will be what I'll be left with, the shaded area. So area of sector AOM. Area of triangle is easy for a right angle triangle, which is half base times height. I can use it. I'm not using the one given in the formula sheet because this is easier. Half base, I'll take, because 90 degrees there, so 5 becomes the base, 12, which I just found out, becomes the height. So times 5 times 12, half base times height, minus area of sector is half area of any sector. The formula is in your formula sheet, half r square theta. So it will be half, r is 5 square, theta we just got 1.18, not 118. Okay, so 1.18. all right, so this will be 30 because this cancels out. 6 times 5 is 30, minus 25 divided by 2, 12 times 5 times 1.18 comes out to be 15.3 centimeters square. That is the area of the shaded part. Find the x coordinates of the stationary points of this only x coordinates. Okay, the stationary point, what is a stationary point? This is a stationary point, this is a stationary point where the graph changes its direction. So if I draw a tangent on it, that becomes the gradient of that stationary point. Yeah, and since the gradient of a horizontal line is 0, the stationary point's gradient will be 0, and that is nothing but dy over dx. That is the gradient of any graph. So we'll differentiate this and make it equal to 0 because the gradient is equal to 0, right? So these two parts are multiplying. That means we can use product rule. So half I will not touch because it's a constant. I will just find dy dx differentiation of the other two parts. Okay, according to product rule, I will not touch the first one. So 3 minus 2x, I'll keep at it as it is, but I will differentiate x plus 2 square. So I will differentiate the second part, plus I will not touch the second factor, I can say it, but I will differentiate the first factor. This is what I'll do. Okay, so it becomes half 3 minus 2x, and the differentiation of this will be 2 will come in front first, so it will multiply it by 2. X plus 2 will have its exponent reduced by 1, so 2 minus 1 is 1, so I'm not writing it. Further we'll multiply what is the content of the bracket, which is chain rule. Yeah, and the differentiation of x plus 2 is 1. There was no need for that to write, but I'm writing it still. I don't want anything to stay out of it. So second part stays same, but this will be differentiated, and differentiation of 3 is 0. Differentiation of minus 2x is minus 2. So since I have to make it equal to 0, I have to factor this also. So half will remain outside. 3 minus 2x is here, nothing here. X plus 2 is here, and x plus 2 is here as well. So let's take that common. So if x plus 2 is out, what is remaining in the first part? 1 times 2 is 2. So 2, and x 3 minus 2x is still remaining. Okay, So this and this I wrote inside, then plus x plus 2 square. So x plus 2 is already out one of them, so second x plus 2 will stay and minus 2 will also multiply with it. So x plus 2 and minus 2. Okay, let's simplify this curvy bracket. So half x plus 2, and now I can write on the bracket 2 times 3 is 6 minus 4x, then minus 2 times x is minus 2x minus 4. So equal to 0, equal to 0, and now it becomes half x plus 2, 6 minus 4 is 2, and minus 4 minus 2 is minus 6x equal to 0. Now two products are equal to 0, that means one of them is 0 or both of them are 0. So we'll take both of them as 0. So x plus 2 equal to 0 will give us x equal to minus 2. This is one of the x coordinates they are asking. Find the x coordinate, right? And this one will give me 2 minus 6x equal to 0, which becomes 2 equal to 6x. So x equal to 2 over 6, which is 1 over 3. This is one x coordinate, this is another x coordinate, and I did not take half into account because half is not equal to 0. It cannot be, so ignored that one. These two give us these two answers. These are the x coordinates of stationary points. Okay, let's move on to B part. On the axis, sketch the graph of this stating the intercepts and coordinate axis. Okay, so first of all we can see that we have two stationary points, so we'll have to find the y counterparts of them. So let's find y counterparts of them first. Minus 2 was 1, and this is the function. So I'll find y when x is equal to minus 2. So x is equal to minus 2, I'll put here in this, so it becomes half 3 minus 2 minus 2, then minus 2 plus 2. Oh wow. So this becomes 0, this whole thing becomes 0. That means the coordinate, y coordinate of this is minus 2, 0. This is one stationary point. By chance it is the x intercept also. Alright. What about the second one, 1/3? So I'll put it here. 1 over 2, 3 minus 2 times 1/3, and minus 2, no, 1/3 plus 2 square. Okay. So it comes out to be 3 minus 2 over 3. So 9 minus 2, 7 over 3. And this comes out to be 6 plus 1, 7 over 3 square. So it becomes 7 over 3 cube, because square we get from here and 1 we get from here, so it is cube. So let me evaluate. That is equal to 343 divided by 20 and 54. 343 divided by 54. 6.351. So 6.35. This was one stationary point. Second stationary point comes out to be 1/3, 6.35. Now we need to find the intercepts. They said stating the intercepts with coordinate axis. So we got one intercept already, which was this. Where did we get it? This one, minus 2, 0. But what about the second or third, if there is any? So let's do it. So I'll use this space to get intercept. So first, x-intercept. So in x-intercept, y is equal to 0. So this becomes equal to 0. 3 minus 2x, x plus 2 square. This already we got x equal to minus 2. So no need to look at this. This will give us what? 3 equal to 2x. So x, I made it equal to 0, okay? 3 minus 2x equal to 0, because For x-intercept, I'm making y equal to 0. So x is 3 over 2. So this becomes our second x-intercept. What about y-intercept? For y-intercept, x will be 0 in the main equation, this one. So y equal to half 3 minus 2 times 0? 0. What about the other one? 0 plus 2. 2 square is 4. So it becomes, okay, this can cancel here. So 3 times 2, 6. Y equal to 6. So 0, 6 is your y-intercept. We got 2 x-intercept, 1 y-intercept, and 2 stationary points. I think we are ready for our graph. So let me put this x equal to minus 2. The first x-intercept, minus 2. So this will be our x-intercept. Second is 3 over 2, 0, positive 3 over 2. So this is 2, so 3 over 2, 1.5 will be here. This is our x-intercept. Okay, what about the stationary points? Y-intercept is also there, no? 0, 6. So let me say the 6 is here. Though it is not according to the scale, but positive 6. This is our y-intercept. And stationary points. First one was, this one is the stationary point, oh, minus 2, 0, this one. Okay. Second stationary point was 3, oh, this one, 1 over 3. Let me show you. 1 over 3 was x in the x coordinate, and y coordinate is 6.35. 1 over 3 positive will be somewhere here, and 6.35 will be more than this. So we have all the points which we have to join now. So it's a cubic function. Yes, it's a cubic function. So, and leading coefficient is negative 2x, right? So negative. So it will start from here. And this is a stationary point. Minus 2 is a stationary point. So it will, I hope you are aware that with a negative, because of this minus 2, the negative coefficient will be there, and it starts from second quadrant. Okay, and because this is a stationary point, we'll go back and we will pass through 6. Then stationary point is again at 6.35, and then we will come down through this. This is the sketch of the graph where we have taken care of every point. Question 3. Solve this equation giving your answer to 2 decimal places. What is unusual about this question is the power, and I hope you have never done such thing. So let's do what? Let's simplify that power. How? Let's assume that x to the power 3/5 is equal to an alphabet, say t. Okay, so what does this become? 60 plus 1 equal to 12 over t. Simplified. Now let's get rid of this denominator t. So what will we do? We'll multiply the whole equation by t, and that will give us a new equation, which is 6t square if t multiplies with this, plus t equal to, when 12 over t multiplies with t, t and t cancel, equal to 12. That gives us a quadratic equation. Okay, now we need to factorize this one to get values of t. I will use splitting the middle term. You can use calculator or quadratic formula. So 6 times 12 is 72, minus 72 I want plus 1. So 9 and 8 can work. So plus 9t minus 8t minus 12 equal to 0. So what is common in these two? 3t. So 2t plus 3, and the common between these two is minus 4. 2t plus 3. So it comes out to be 2t plus 3, 3t minus 4 equal to 0. Now again, two multiples or factors, they multiply to make it equal to 0. That means either this is equal to 0 or the other one is equal to 0. So this gives us 2t equal to minus 3, t equal to minus 3 over 2. This gives 3t equal to 4. So t equal to 4 over 3. Now t was not our question. Our question was x to the power 3/5. So x to the power 3/5 is equal to minus 3 over 2. Second answer, x to the power 3/5 is equal to 4/3. Now, to evaluate x, what will we do? We will give, there are two ways. We can use logs or we can do this. Give this a power of 5 over 3. So 3/5 given a power of 5 over 3. So is the other one, 5 over 3. We can't give only one, we have to give to the other one also. What is the purpose? So that 3/5 and 5/3, they multiply and become 1. So x is equal to this. I will use my calculator to find this. Similarly here, x will be equal to 4 over 3 to the power 5/3 by same process. I'll just put these two in my calculator and I will get the answer. By the time I do this, I would request you to like this video, share with your friends and subscribe to Math United. What I'm getting in this one is x equal to negative 1.9655, so I'll say 97. 2 is at decimal places, that's what they want. And this will be 1.615, so 1.62. These are the two answers of this question. For A part, a team of 10 players is to be chosen from 15 players. Find the number of different teams that can be chosen if there is no restriction. No restrictions means there is 15 total number of players. We have to select 10. So 15 C 10, whatever that is, I'll evaluate that later. The 15 players include 3 sisters who must not be separated. That means either they are in the team or they are not in the team, right? Find the number of different teams that can be chosen. So they are in the team or not in the team. In these two ways, they are not separated, right? So that means they in the team means their position is fixed. So now only 12 people are left, out of which we have to select 7, isn't it? Because 3 girls are already there in the team. So out of the remaining 12, we need 7. That is the one. Plus not in the team. That means they are already out. So we have to select all 10 from the remaining 12. All 10. Yeah. Just add these and we'll get our answers. Let me evaluate this, this and this, all 3 together. By the time I do this, I would request you to like this video, share with your friends and subscribe to Math United. What I'm getting here is 3003 and here the total of the two is 858 ways the 3 sisters will not be separated. Next, B part. A 6-digit number is to be formed using these. So how many are they? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. The 6-digit number cannot start with 0 and all 6 digits must be different. Okay. Find how many 6-digit numbers can you form if the 6-digit number is even. Alright. Since they have 0 cannot be the first one and 0 also makes it even. So let's make 2 options. 6 digits where 0 is the last digit. Okay. And second option when 0 is not the last digit but it is still even. So what are the other options for even? 2, 4, 6 and 8. Right. Now let's take this one. This 0 is the only option in the last digit. Yeah. Now the leading coefficient, leading number cannot be 0. So it is already used here, so there is no effect. Remaining 9 will be here. And for the second space, 1 is used here out of 9. 0 is already used here, so remaining are 8 here. And 7, 6, 5 for the remaining spaces. So this is what number of possibilities are there with 0 at unit place. What about this? There are 4 options here. 2, 4, 6, 8. There are total 4 options. Now here, one of them has been used in this unit digit. Now 0 cannot be used here. That means there are only 8 options here. In second one digit has been used here. 1 digit has been used here. Again, there will be 8 options here, including 0 now. 0 can be in the second space, right? And then will be 7, 6, and 5. Multiply them. This will be our second option. And we will just evaluate them and add, and we'll get our answer. According to me, this comes out to be 15, 1, 2, 0. Then we have more here, 53, 7, 6, 0. And the total in this case will be 8, 8, 8, and 6. 68,880 combinations possible. Question number 5. When e to the power y is plotted against x square, a straight line graph, a gradient of -3, very steep and going down, is obtained. The line passes through the points 4.30. So let's say this is the point 4.30 and 5.85. It passes through this point. Okay, and this is a straight line graph with these axes. Find y in terms of x. So first let's find the y-intercept with the help of line of a straight line, equation of a straight line, which is y equal to mx plus c. If you notice, I'm using capital Y and uppercase X, y, because they are not usual x and y in axis. So I will substitute them by e to the power y and x square later. First I will find the equation here. With the help of this 1 point and gradient -3, I will find c. So y is 5.85 in this on this line. Gradient is -3. 4.3 is the x coordinate, 4.30, and c is left here. So that means c becomes 5.85 plus 12.9. Okay, which is 18.75. Okay, so we got C, positive 18.75, and that makes sense, right? It is above 5.85, that's right. Now, they want us to express y in terms of x, and we'll bring back the actual ones, which are e to the power y. So in place of y, I will write e to the power y equal to -3, which was the gradient. X is x square, not x anymore. And c, we just got 18.75. Okay, now we have to isolate this y. Whenever we have to remove e from e to the power y, we apply natural log to both sides, because natural log is inverse of e, exponential. And we cannot apply natural log with individually the other ones. We will apply it with the whole single natural log. Okay, now e and natural log, since they are inverse of each other, they cancel out, and y becomes natural log. I'll write the positive one first, 18.75 minus 3x square. This is y in terms of x. Some of you may confuse that because of minus we can divide them. No, there is no rule of minus being converted into division. That is a very big misconception. That is division converted to negative outside. So no need to do anything beyond this. Okay, don't be over adventurous. Okay, so we have B part also. Find the value of x for which y exists. So y will exist only if the natural log is more than 0, right? If I look at the graph of a natural log, it is something like this. Can you see? It passes through 1 here, and it is never in negative zone. So the content of natural log has to be equal, or so not equal, more than 0 always. So 18.75 minus 3x square has to be greater than 0, and that will give us the situation where we can find the condition. So let me bring 3x to the other side. So 18.75 is greater than 3x square rather, which is what? 3x square is less than 8. It's the same thing, right? I should write the variable on the left side, so I changed it, and because it was lower side here, so I wrote it this. So x square is less than 18.75 divided by 3, which is x square is less than 6.25 and square root both sides, which means x is less than 2.5 or x is greater than minus 2.5, because square root will give us positive and negative. In case of negative, we change the sign. So our answer could be that minus 2.5 is less than x is less than 2.5. Okay. Question number 6. It is given that y is equal to this, find dy over dx, that means differentiate it. So dy over dx equal to, we have to differentiate this, that means we'll use quotient rule because there are two variables which are dividing. For quotient rule, if you remember, u v minus or v u prime equal v square. So whatever is the denominator, we square the denominator because it is v square, so x plus 2 squared. Then we write v x plus 2, and then we differentiate whatever is the numerator, natural log of 2x square plus 1. Okay, minus u remains u, that means the natural log, this will be differentiated, natural log 2x square plus 1 remains what it is, but x plus 2 will be differentiated, and that will give us our dy over dx. So x plus 2 remains x plus 2. The natural log of 2x square plus 1 will be 1 over 2x square plus 1. It reciprocates first, and then we multiply by the differentiation of whatever is the inside the content of natural log, which is 4x plus 0, so 4x, just 4x. Differentiated chain rule. Minus x plus 2, its differentiation will be 1, so no need to write, we'll just write natural log 2x square plus 1, okay, divided by x plus 2 whole square. And they are asking us to just find dy dx, so let's try to simplify this. Okay, we have a denominator here, 2x square plus 1, so let's give it also a 2x square plus 1 numerator and the same denominator. Okay, it is not content of natural log, it is additionally multiplied with this. Now both of them have same denominator, so denominator of a numerator is also denominator. So this x plus 2 whole square is already there, so now new denominator will come, which is 2x square plus 1. And I will just open up this. 4x multiplied by x is 4x square. 4x times 2 is 8x minus 2x square plus 1, and we cannot do anything about it. We have to multiply by natural log 2x square plus 1. We cannot take anything common here. Okay, that's it. This is our dy over dx. Okay, given that x increases from 2 to 2x, okay, so where h is very small, when h is very small, dy over dx becomes delta x and delta y. That's how we write it. Okay, so they say that when x becomes 2 plus h, in such case delta x will become the change, which is h. Delta y we have to find, and x, it came from 2, so it is almost 2. We'll substitute it by 2 only, minus 2 times 2 square plus 1 natural log 2 times 2 square plus 1 divided by 2 plus 2 whole square and 2 times 2 square plus 1. Okay, it becomes how much? 4 times 4 16 plus 16 minus 4 times 2 is 8 plus 1 9 natural log 9 over 4 square is 16 and that is 9. That is h over delta y. We want to find delta y. So I'll bring delta y to the other side by cross multiplication. H will remain where it is, this h. However, this will cross multiply with h. So 16 times 9 is 144. And this 32 plus 32 minus 9 natural log 9 will come down. So this is delta y. This is the change in y when x is 2 and there is a small change of h. Okay. Given that y is increasing by 0.4 per second, so they have introduced time. Find the corresponding rate of change. Rate of change again means with respect to time in x when x is equal to 2. And go here. This was dy over dx, right? This was dy over dx. So let me rewrite this. Dy over dx is equal to 4x square plus 8x minus 2x square plus 1 natural log 2x square plus 1 divided by x plus 2 square 2x square plus 1. Okay, now they're saying that x is changing at y is decreasing at 0.4. That means dy over dt, and there is no t here. So what will I do? I'll just add t. Not add, sorry. I'll divide both numerator and denominator by dt. That makes with respect to time now. They're saying that dy over dt, it is decreasing at 0.4, so it becomes minus 0.4. And dx over dt we have to find. At what rate the dx is increasing or decreasing, that's what they're asking. However, they're saying when x is how much? 2. When x is equal to 2. And when x is equal to 2, we already got it here. This part, we got it 32 minus 9 natural log 9 over 144. Yeah, this is what we got. That's what we'll do. So, 32 minus 9 natural log 9 over 144. Now, we want to find dx over dt. So, we'll cross multiply again. It comes here, dx over dt. And this is 0.4 times 144. Whatever we did in previous part, same we are doing here. 32 minus 9 natural log 9. That is the rate of change in x, which I think will be negative again. So let me use my calculator to find the left side. That will be the rate of change in x. By the time I do this, I request you to like this video, share this with your friends, and subscribe to Math United. What I'm getting, dx over dt, is minus 4.7118. Okay, so we'll stay with 3 segment figures. Minus 4.71 units per second. Question number 7, it is given that this is a function for x is greater than 0 where a is an integer. Gx is this for x is greater than 1. Find the least value of a so that the function gf exists for all x to the greater than 0. So gf, that means g is the parent function and fx is the daughter function. What will that be? So that is the main function, that means square root. And in place of this x, we will write whatever is in fx. So 2e to the power x plus a, and then in function I have minus 1, right? Okay, find the least value of a so that the function gf exists. So what will be the value of this so that a square root is possible? Is the square root of a 0 possible? Yes. Is the square root of a number negative which is less than 0 possible? No. That means this has to be 0 or more than 0. So 2e to the power x plus a minus 1 has to be 0 or positive, which means this x is greater than or equal to 0. That means e's power will be 0 or more, right? So we can write that e to the power 0 is 1, yeah? So it will be more than that value. So 2 times 1 plus a minus 1 greater than equal to 0. 2 minus 1 is 1, so a plus 1 is greater than equal to 0. A will be greater than equal to minus 1. So these are the values of a greater than equal to minus 1. However, they asked us the least value. So what is the least value in this range? A is equal to minus 1 is the least value. Okay. B part, in the case where a is equal to 5, solve the equation gf x equal to 3. gf was this one. Okay, so gf. So I can write here, which was this one, right? So square root 2 to the power e x plus a minus 1 is equal to 3. A is equal to 5. That means 2 e to the power x plus 5 minus 1 equal to 3. Give your answer to this and we have to solve this equation. Okay, so let's get rid of the square root first. We'll square both sides. So this is square and square root cancel out. 2 e to the power x plus 4 equal to 9. 4 will come to the other side. 2 e to the power x equal to 9 minus 4. So e to the power x is equal to 5 divided by 2. So whenever we want to remove e constant from one side, the other side will become natural log. Okay, that is the value of x and they want 3 decimal places. Let me use my calculator for this. By the time I do this, I would request you to like this video, share with your friends and subscribe to Math United. What I'm getting is 0.91629. Okay, so 916, 3 segment figures. Question number 8, A part says that show that this can be written as sine cube theta. So what they're asking us to prove that sine theta tan square theta over 1 plus tan square theta is same as sine cube theta. So this is LHS. I will focus on LHS to get RHS. Okay. So can I convert tan square into sine square over cos square? So sine theta was already there on LHS. I'm going to write sine square theta over cos square theta divided by 1 plus tan square theta is secant square theta. Okay, so what does this become? The numerator will multiply with numerator, so it becomes how much? Sine cube theta over the denominator of numerator is multiplied with the denominator, so cos square theta will multiply with secant square theta. And we know that secant square theta is reciprocal of cos square theta. They are reciprocal of each other, so they will multiply to get 1. And we are left with sine cube theta. Shown. B part says, hence solve this equation equal to 8. So does it have everything? Sine theta tan square 1 plus tan square equal to 1 over 8. Okay. So this equation becomes, the format will be this now. Sine cube theta, which is sine cube 3x now, equal to 1 over 8. Right? I can substitute the left side with its equivalent got from the A part, because this thing hence. Alright, cube root this and cube root this to get rid of cubes. So sine 3x is equal to 1 over 2. Our domain is minus 180 to positive 180. Okay, so 180 positive is here and minus 180 is also here. So we want from starting from here till here. Okay, so 3x equal to sine inverse half. Okay, so we will take care of 3 later. First we'll say what is this sine inverse half equal to. Sine inverse half is equal to 30 degrees. Yes, 30 degrees. Okay. However, they said minus 180 to 180. Okay. And now I should get this 30 degree first on my this particular quadrant here. So 30 degree here, and this 30 degree is not x, it is 3x. Okay. So it's positive. So sine is positive here, sine is positive here as well. So this will also be 30 degrees. Nothing in negative right now. Okay. But we'll see if something can be gotten in negative as well. So first I will try this one. First answer, 3x1 will be the actual 30, this one. So x1 comes out to be 30 divided by 3, which is 10 degrees. Okay. Now second answer, 3x2 will be starting from here and reaching to this line, which is 180 minus 30, 150. And x2 will be 150 divided by 3, which is 50 degrees. So 10 and 50 both lie in our domain. That's okay. Let's see if I go beyond this. So I'll go 360 pull plus 30. So third answer, 360 plus 30. Okay, so x3 comes out to be 390 over 3, which is 130 degrees. Perfect. Okay, so we got 3 answers now. If I go even beyond, it may not work, but I will try. So if I go 360 plus 180 minus 30. Okay, so let me continue here. 3x4 is equal to 360 plus 180 minus 30, because it is 3x, so we need to go this way. So 540 minus 30 is 510. 510, 40 minus 30, yeah. So 3x4 is equal to this. So x4 equal to 510 divided by 3, which is 170. Okay, we got fourth answer also, which is within our domain. Obviously, it is very close to 180, so I should not go to one more round, but I will go backwards. I'll go, this is minus 180 minus 30. So let me go to the right so that I have more space. So 4 answers already there. Let's say 3x5. I will reject the one which will not work. So I get minus 180 minus 30. So x5 comes out to be minus 210 divided by 3, which is minus 70, well within our domain. This is also okay. 3x6, one more answer. So I'll go minus 180 minus 360 plus 30. Minus 360 plus 30, which is x6 is equal to minus 330 30, which is minus 110. Let me try for x7, which is even beyond that. Let's see, it may not work, but I will try. Okay, so minus 180 minus 360 minus 180. So minus 360 minus 180 and again minus 30 more. So x7 comes out to be 540, 570 minus 570 over 3, which is minus 190 degrees. We do not want this. This is out of range. Reject it. So we are satisfied with 6 answers. Minus 110, minus 70, 30, 50, 10, and there is one more, which is 170. Question number 9. In this question, all lengths are in meters. Time is in seconds. Okay. A particle P moves in a straight line such that t seconds after passing through a fixed point O. So let's make a point O. This is O. Here time is 0. Displacement h is given by this. Okay. Find the value of t for which p is instantaneous. For which p is instantaneously at rest. Okay. So instantaneously at rest means velocity is 0 at that moment. Okay. We don't have an equation for velocity. So what will we do? Velocity is nothing but the rate at which displacement happens. So I'll just differentiate this. 5 natural log 2t plus 1 will be 5 1 over 2t plus 1. That's how we differentiate. With chain rule, I have to differentiate the content of natural log also, which is differentiation of 2t plus 1, 2. Then minus differentiation of 5t is 5. So it becomes 10 over 2t plus 1 minus 5. And we have to make it equal to 0 for instantaneous rest. And we have to find t. So 10 over 2t plus 1 equal to 5. Cross multiply. 10 equal to 10t plus 5. So 5 goes to the other side. 10 minus 5 equal to 10t. And t comes out to be 5 divided by 10, which is 0.5 seconds or half second. That's the value of t when it is at instantaneously at rest, which means it changes its direction. Alright, next. Find the distance p. Distance, Distance makes it difficult. P travels between t equal to 0 and t equal to 2. T equal to 0 and t equal to 2. Look, it starts from here. So t equal to 0 is here. After 0.5 seconds, it is instantaneously at rest. That means it changes its direction. So 0.5 seconds, it goes to in one direction. After 0.5, it goes into other direction, and there is no change after that, change in direction. So they're saying between 0 and 2, that means we have to find for 0.5 separate and 1.5 seconds separately. Total 2 seconds. Why? Because they're asking distance, not displacement. So first we'll find the displacement from 0 to 0.5 and then 0.5 to 1.1, which is this. So 5 natural log 2t plus 5 plus 1 rather, not 5, minus 5t from 0 to 0.5. And then we'll do same 5 natural log 2t plus 1 minus 5t from 0.5 to 2. Okay, two pieces. So we'll substitute 0.5 first. So 5 natural log 2 times 0.5 is 1. 1 plus 1, 2. Minus 5 times 0.5, 2.5. Minus 5 natural log 2 times 0 is 0. So this will be left with natural log 1, which is also 0. So no need to write. I will just erase this. This will be 0. I'm doing mentally. You can just substitute your numbers here and you'll get it. So 0. And 5 times 0 is also 0. Okay. So this is also gone. So there is no point in this. Just this is the distance from 0 to 0.5. What about this? So since we got already from 0.5, which is this, so let me write minus 5 natural log 2 minus 2.5. This one I copied for 0.5, but this 2 I have to substitute. So I will do it here. 5 natural log 2 times 2 is 4. 4 plus 1, 5. Minus 5 times 2, 10. Minus this. By the time I use my calculator, I will request you to like this video, share with your friends, and subscribe to Math United. A lot of effort goes into making such videos. So this one is coming to be 0.9657. I will write all the digits because I'll be getting exact answer because of that. So this is coming out with this, and what I'm getting here is minus 2.9185. Let's have 4 digits. So since this is in opposite direction, we can see it is in opposite direction coming out to be negative, but we want to find distance, so we'll have to absolute it. So our distance, total distance, will be 0.9657 plus 2.9185, which comes out to be 3.8842. So 3.88 meters. We can write 3.88 meters. This is the distance from 0 to 2 seconds. We have another part. Find an expression for acceleration of p in terms of t. Acceleration. So since we already know velocity, here we can find acceleration also. So let me write it here. Acceleration is dv over dt. The rate at which velocity is changing is acceleration. So v is equal to this, right? So I will just differentiate this. Okay. So minus 5, its differentiation will be 0. So don't look at this. Just we'll focus on this. Can write this as 10 multiplied by 2t2 plus 1 to the power minus 1. And I have to differentiate this. I'm ignoring minus 5 because its differentiation will be 0. So it will be coefficient, the constant remains constant. Minus 1 will come in front, and the coefficient of, so exponent of 2t plus 1 will go down by 1, which is minus 2. And further we have to multiply what is inside the bracket. So we differentiated it. Differentiation of 2t plus 1 is 2. Okay. So minus 10 times 2 is minus 20. 2t plus 1 to the power minus 2 is your acceleration. But the question was, find acceleration in terms of t. Okay, done that. So that is the answer. If you want to write simplified version of this, you can write this. Acceleration is minus 20 over 2t plus 1 square. There is D part also. Find the acceleration when t is 4.5. So that means in this acceleration we'll have to put t equal to 4.5. So acceleration equal to minus 20 over 2 times 4.5 plus 1 square minus 20 over 4.5 times 2 is 9 plus 1, 10 square is 100. So which is minus 0.2 meters per second square. Okay, got it. Question number 10. The expansion of this power 4, power 3 is written descending power of x. First three terms are these. So they will be enough, I think. It is given that a, b, and c are positive integers. Okay. So we will expand them separately. Let me expand this one first. Ax minus 2 to the power 4. Let me expand this in descending order. So 4c4, I'll give ax the whole power. This formula is in your formula sheet, and minus 2 will be given nothing. So we got power 4 from this. Then 4c3, this power will go down by 1. So 4 goes to 3 and minus 2 to power 1. Okay. So we have power 4 total. So we'll have 5 terms. I'll use the ones I want later on. 4c2, okay, so I have expanded both of them, and I will see now. I'll focus on 81x is 4. 81x to the power 4. The first one. I will see which one will give me power 4. See, this will give me power 4. Right? And nothing from here can give me power of 4. But if I multiply this power of 4 with the constant, this is constant, right? B to the power x. B over x to the power 0 will be 1. This is 1, so this is constant. So 1, 1 and 1. So this is 1. This multiplied by x to the power 4 will give me x to the power 4. There is an x square here. There is an x square here also, which is here, but it is denominator, right? So they will cancel out. They will not be same. So there is no x square in this. So I will equate 81 over x4 to this one only, which is 4c4, which is 1, a to the power 4, x to the power 4, and minus 2 to the power 0 is 1. Okay, so it means a to the power 4 is equal to 81, because x to the power 4 and x to the power 4, they cancel out, and a comes out to be the fourth root of 81, which is 3. Now let's focus on x 999 x cube. So 999 x cube. How will we get x cube? Obviously, when this multiplies with this, will give us x cube. But since this is 1, we don't have to worry about this. This will give us x cube, which is 4c3. 4c3 is 4. A cube. Let's not write a cube. We know a now. So we can write 3 cube. Okay, and then minus 2. All right, and x cube. All right, now x4, this x4, if multiplies with this divided by x, will also give us x cube, isn't it? Let me do it separately first, and then I will move it here. So x4 was how much? It came out to be 81x4. Yeah, 81x4. Yeah, 81x to the power 4 multiplied by this term, which is 3c1, 3, multiplied by b over x to the power 1, b over x, and 1 square is 1. Can you see? This is 4, this is worse, so they will cancel and it will become x cube. So I have to use this also. So I will use 81 times 3b x cube. 81 times 3b and nothing, no need to write 1. This is our second x cube. So we can ignore x cubes first. Let's ignore this, and ignore this. 999 is equal to, how much is that? 4 times 27. 108 minus 2, 216. Okay, 81 times 3 is 243b plus 243b is positive, 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 minus 2. Okay, positive. So 243 remains here, 243b, and 999 plus 216 equal to this. So b comes out to be, it will be 1215 divided by 243, 5. So b came out to be 5. Now we need to use c, and let me use the upper space for c. Cx square. Cx square will be equal to, obviously x square is here, so this will be one of the sum. So 4c2 a square x square and positive 4 minus 2 square will be positive 4. This will give x square by multiplying with this 1. Okay, what about an x cube divided by the same x, this one? So x cube divided by this will give me x square. So plus x cube. What did we get for x cube? Let me use the straight away what I got here. The x cube we got was this one, right? This one, which was minus 216 x cube. Minus 216 x cube. To make it x square, I'll have to multiply with the x here, this one, which came out to be, I did it earlier here, 3b over x. Yeah, 3b over x. That's what we'll use here. So 3b, b is known to us now, 5 over x. And see, this will give me x square. There will be one more x square when x to the power 4 on one side, x to the power 4, this one, multiplies with x square. Wherever we have, this is x square. This will also give us an x square. So we had what, 81 x to the power 4, right? So I'll write somewhere, I will write it. I'm trying to make it as clean as possible. So 81 x to the power 4. This was the expansion of this. It will multiply with this to give me x square. So times 3c2 is 3, b square over x square. B square is 5 square over x square, and then 1 to power 1 is 1. So this x square cancels with this, it will remain 2. So 25 times 3, 75 times 81. 75 times 81, is it negative or positive? We'll have to be very careful. This is positive. What about this one? This was 4 power 4. That's not positive. Okay. 81. This is what will give us x square again. Okay. Is there any other possibility of getting an x square? No. So we'll just do it. 4c2 is 6a square. A is 3. Times 4. Let's cancel x square from both sides. C equal to minus this x square goes 15 times 216. And here we get 75 times 81. So we got 3 for x square, which will give us c. C comes out to be 3051. Question number 11. Solve the equation cot of this where y is in radians between 0 and 6. 0 and 6 in radians. So it is 0, radians 3.14 here, 6.28 here. Basically, it is very close to 2 pi. Alright. Cot. So cot is 1 over tan. So we can write tan y plus 1.5 equal to, I reciprocated this. That does not mean I reciprocate this because it's an identity, equal to 3. So tan goes to the other side. So tan y plus 1.5 equal to 1 over 3 cross multiplied. This went there, it came here. Alright. So y plus 1.5 equal to tan inverse 1 over 3. That means y is tan inverse 1 over 3 minus 1.5. Since our answer is being subtracted by 1.5, so I'll have to see tan is positive here and positive here. I'll not only use this, I will use the next round also because they are positive, right? So can I go negative? I'll see. First I'll answer the positive ones. So first I'll put tan inverse 1 over 3 in my calculator and see how much it is. I'm getting 0.32175. So I can write it this as 322, 0.322. So I will not use minus 1.5 right now. I will first evaluate this and write 0.322 in the quadrants where it is positive. So 0.322 and 0.322. So the first answer will be from 0 to here. So y1 equal to 0.322 minus 1.5, which is a negative angle. We can't take it. Next one, I'll again write y1 because it was rejected. Okay, second one is this one, which will be pi plus 0.322. This is the tan inverse 1/3 minus 1.5. This may give us some answer. It is giving us 1.963. So I can write 1.96 radians. That is the first answer. Let's go to another part, which is we want positive, right? So we'll go to this angle. So y2 equal to 2 pi plus 0.322 minus 1.5. So what does this give us? 5.1051. So 5.11 I can write. 5.11, which is also okay. Will this give us some answer? Means further, let's see, y3. So 2 pi plus pi more plus 0.322 minus 1.5. I don't think it will give us an answer, but let's see. 3 pi plus 0.33322 minus 1.5. 8.246. So it is crossing, so no, reject it also. So in both directions we rejected 2. These are our answers.